Okay, so today we are going to prove these 6 theorems. Okay, so before we start with that. Let's get a good idea what does A by B means. So when we write A by B, it means that first one is, or the first point over here is like A divides B. Okay, or B is a multiple of A. Or the third point is, if we are explaining this, B equals to A into some integer. Correct. Let's get an example. 2 by 8 means that, or it is true, because eight equals to 4 into 2. 3 by 12 but 3 is false, because 10 is not equals to 3 into some integer. Alright, so after this we have got an idea. So let's start with theorem 1, part 1. Part 1 says, if A divides B, then A divides BC, right, for any integer C. So what does this means? It means that if you're writing in a single term or a single line, if A divides B, then A also divides B multiplied by anything. Okay, so we are getting that idea from here. Why, and why is that true, and why should it be true? Because if is B, if A divides B, then then we can write that B equals to A into Q, right? A multiplied by Q, where Q is any integer. Okay, right. Now, if we multiply both side by C, we get BC equals to A into Q into C, right? Therefore, BC is equals to A into A into QC. correct? And as QC therefore A divides BC, correct? All right. So what we can say that by another number does not break divisibility, right? All right. Now let's move on to the next one. It's A divides B and B divides C, then A divides C. It means that and B divides C, then A C. Why is it true? Okay, let's get an idea by the following that if A divides B, we can say that B equals to A into Q, and if B divides C, we can say that C equals to B into, suppose this be Q1 and then B into Q2. So these are different integers. All right. So from here we can say that substituting B over here, we can say C equals to A into Q1 into Q2. Therefore, C equals to A into Q1 Q2. Correct. Therefore, A divides C. Hence, divisibility passes down. All right. Now let's get to the third form, right? If A by B and A divides C, then A must also divide BX plus CY, right? So why should it happen? Let's see. If we say, we are saying So we are saying that if Q2, right? Now, if we say, so we can say from here is that bx plus cy, this would be equal to aq1 into x plus aq2 into y, right? So from here we can say that a, if we take a common, it's q1x plus q2y. Therefore, since this whole thing is an integer, we can say a divides bx plus cy. Okay, as you can see over here, we have got a over here, right? So if we are writing bx plus cy, we can write it divided, like suppose we are trying to prove by a, right? So we can write over here in place of bx plus cy, a into q1x plus q2y by a. See, it's easily divisible by a. So we can say that all right, fine. Now let's go to the next one. It says if a divides b and b is not equals to 0, then a is greater than equals to mod a is greater than equals to mod b. All right. What does mod means? Absolute value of c. Okay. All right. Why is that? If a divides b, we can say that b equals to a into q, right? Then we can also say that mod b equals to mod a mod q, as modulus distributes and since q is an integer and q is not equals to 0, that means q is mod q is greater than or equals to 1, right? So from here we can say that mod b is greater than or equals to a or mod a. So hence proved. a divisor cannot be larger than the number. We have an exception, that is a zero case. All right. Now let's go to the next proof. This proof is if A divides B and B divides A, then A is equals to plus minus B. What does this mean? That if both of these two are true, if both this one is true and this is also true, then A and B are same number, maybe opposite signs. Why is that? From the previous one, from 4, we can say that if A divides B, it means mod of A is greater than mod of B, correct? And if B divides A, we can say that mod of B is greater than equals to mod of A, right? So from both of these equations, we can come to a overlapping conclusion that mod of A equals to mod of B, and this means A equals to plus minus B, hence proved. All right, now let's go to the sixth question. All right, the sixth question. If M is not equals to 0, then A divides B implies MA divides MB. So that means we have to prove we have to prove by the same non-zero numbers does not change. Divisibility. Right. So if we are going in the forward direction, we can say that if A divides B, then B equals to A into Q, right? Now if we multiply n on the both side, m on the both side, Bm equals to A into Q m, correct? Correct. So that means MA divides MB. Now let's go from the backward direction. If you go from the backward direction, if we go from the backward direction, it goes like if MA divides MB, right? So then we can say that MB is equals to MA into Q, correct? So dividing both side by M, we can get B equals to AQ, or let's divide both side by M. We can say that B equals to AQ. Right. Therefore, A divides B. So multiplying by a non-zero number keeps divisibility true. Correct. Keeps divisibility true. So here are the certain rules, okay, that we have to remember. Divisibility is stable under multiplication. Divisibility passes through chains. Divisibility works with addition. Divisors are smaller than the number. Mutual divisibility means numbers are equal up to the sign, and then multiplying both sides doesn't change divisibility. Thank you.